Time to graph a trig function. What is the answer? Who knows? Let's just talk about it first. The amplitude is the absolute value of what's in A's place. The period is 2 pi divided by what is in K's place. The phase shift is, well, determined by what's in B's place, and the vertical shift by what's in C's place. That is, if you are accustomed to this formula. A times the sine of K, x take away B, plus C. Okay, well, let's describe this thing. The absolute value of 2 is 2, so we'll have a vertical stretch of 2. The period is 2 pi divided by half. That ends up being 2 pi times the reciprocal, 2 over 1, or 4 pi. That's our horizontal stretch. It will take 4 pi units along the x-axis to see the full sine figure. We'll shift it pi to the left, and we'll shift it 1 down. Now let's do it. Recall that sine of 0 is 0, so we'll plot a point there. The end of the period for this function is 4 pi, even though we know that the graph keeps going infinitely, both to the left and right. In the middle, at 2 pi, we're going to have an x-intercept, and at 1 pi up to 1, at 3 pi down to -1. Now you may be aware that this cannot possibly be the answer based upon the description that we've already given, because we said that we had to move our graph to the left a whole pi. Well, let's do what we say. Let's move each of these x values to the left. Here's one, to the left, to the left, another one goes left. There they are. They've all gone left. This is our function incorporating the phase shift. You notice that our first draft here in blue, that incorporated only the period to help us figure out the appropriate beginning x values. But then we've got another draft of that graph that makes the x's perfect, where we start at -pi and finish 4 pi later at 3 pi. Time now to take into account the amplitude. That's that vertical stretch. Multiply 2 times all the y values. 2 times 0, can't change that. 2 times 1, 2 times 0, no change. 2 times -1, you're stretching up and down. 2 times 0, let's connect. This is getting closer to the final answer. This third draft, that incorporates the amplitude, the vertical stretch. One last thing to do. Time for the vertical shift. The entire graph is going down. So let's move these y values, all going down 1, down to -1, oops, down to 1, down to -1, down to -3, and down to -1. Time to connect. Ooh, look at that. The final answer. It's everything we dreamed. It does look like sine starts, you know, a little lower, goes high, moves low. It's got a midline. Oh, that midline, look at that. It's at -1. It does stretch 2 above the midline, 2 below the midline. It is good. Time to stop talking.